So today we are going to be talking about a new way that we can solve quadratics. At the end of last week, we had talked about solving quadratics either by taking a square root when there was just an x squared involved, solving by looking at those roots or zeros, finding those x-intercepts when we have a graph. So the new option we're going to use today is solving by factoring. Okay, so obviously this involves the fact that we need to know how to factor, since that's in the title. Okay, but it's all based on one concept in math. Okay, and that concept is that if we have a times b and it equals 0, so if I'm multiplying two random numbers together and they equal 0, then it has to be the case that either a equals 0 or b equals 0, right? That's an or. One of these numbers has to be 0. The only way to multiply two numbers and get an answer of 0 is if one of them equals 0. And that's not true for any other multiplication rule, right? If we have two numbers multiplied together that equal 10, it could be 1 times 10. It could be 10 times 1, it could be 2 times 5, 5 times 2. Okay, so 0 is the only one that guarantees us that one of them has to be 0. Now, the deal is that this a and b could look more complicated. So instead of a equaling 7, I might have a equal to something like a polynomial. So for example, if I have something maybe like x minus 4 times x plus 7 equals 0, right? So here I have two things being multiplied together. I have x minus 4 times x plus 7. So here's my a and here's my b. However, we do still equal 0, which is the key. So if we have this equal to 0, that means that either the first one, which is x minus 4, has to equal 0, or our second one, which is x plus 7, has to equal 0. Now, that doesn't mean that this is our answer yet. It just gives us something that we now know how to solve. Right, x minus 4 equaling 0, we can solve that by just doing an inverse operation of addition and saying x equals 4, or I can solve this one over here, x equals -7. Okay, so this has two answers, which should make sense because last week we said if we were dealing with quadratics, we can have two solutions. Okay, so let's say we're given 3x times x plus 5 equals 0. Okay, so first rule is it has to equal 0. So does this problem equal 0? Yep, check. Then what things do we have being multiplied together? Well, we have 3x being multiplied times an x plus 5, which means either 3x has to equal 0 or x plus 5 has to equal 0. Right, and this is something we can then solve both of them. So we undo multiplication with division. 0 divided by 3 is just 0. Don't turn that into 3. Okay, over here we'll subtract 5. And so we get x is 0 or -5. Now, obviously you could probably assume that this isn't as simple as the problem is because these problems don't really look like a quadratic to start with. Okay, so we want to work sort of backwards into getting to a problem like that. So let's say we're given y squared minus 2y minus 48 equals 0. Okay, so our very first thing to check is, does this equal 0? Yes, it equals 0, so that's good news. Now, what things do we have being multiplied together? Well, we don't have two things being multiplied together right now, right? It looks nothing like these types of problems that we had above. However, hopefully maybe in the back of our mind, because this is called solving by factoring, we're kind of going, now, wait a minute. This is what our factors looks like, our answers look like when we were factoring. So if we just focus on this trinomial here at the very beginning, so if we kind of forget about this equals 0 over here, let's just look at this y squared minus 2y minus 48 and see if we can write it in another way, right? We want it to be equivalent, hold the same value, but look different. So just like we can turn 10 into 2 times 5, right? We can factor this and turn it into its 2 factors. And we do that, okay, it's a trinomial, so we do 1 times negative 48. And then we start listing the factors. So I'm ignoring this 0 over here, and I'm just looking at these 3 terms. So 1 and 48, right? I start listing. 2 and 24. 3 and 16. 4 and 12, 5 and nothing, 6 and 8, 7 and nothing. We want one to be positive and one to be negative, and we want the larger one to be negative. So the set that's going to add up to a negative 2 is going to be a positive 6 and a negative 8. A does equal 1 on this one, so we know we can use the shortcut. So we know this factors into a y plus 6 and a y minus 8. So now instead of saying y squared minus 2y minus 48 equals 0, I can say y plus 6 times y minus 8 equals 0. Right? These two things mean the same thing. They hold the same value. They just look different. And now we do have 2 things that are being multiplied together, right? We can set the y plus 6 equal to 0 and our y minus 8 equal to 0. I can then solve these, so subtract 6, y equals negative 6, and y equals 8. So we get answers of y equals negative 6 and positive 8. Now, how we factor will always be determined based on what the problem is to start with. So this is where we're going to have to use those skills of deciding what format it's in to then decide how we want to factor it. So let's say we're given 5w squared plus 15w equals 0. So very first rule, does it equal 0? Yes, it equals 0, check. Right? This doesn't work if it does not equal 0. It absolutely has to equal 0. So this equals 0, so that's good news. So then we're going to look, okay, this does not have 2 things being multiplied together. So can we look at these 2 terms and factor it so that it is 2 things being multiplied together? Well, how do we factor 2 terms? Well, that's limiting us to either a special case or a GCF. Right, this is not a subtraction sign, so not a special case. Okay, so is there a GCF? Yes, right? This has a GCF of 5w. So if you're struggling with the factoring piece, we need to go back and we need to work on factoring. Okay, hopefully that factoring piece though is like, oh yeah, I know how to factor. So I factor out that 5w, which will leave me with a w plus 3. Okay, so now instead of saying 5w squared plus 15w equals 0, I'll have 5w times w plus 3 equals 0. So I can set both of those equal to 0. So 5w equals 0 or w plus 3 equals 0. Okay, so when we solve, w equals 0. Or w equals negative 3. Now, if you're ever not sure, if you're like, oh, let me check my math, just like we do with any equation, we can take these values and we could plug it back in, right? So you could use a calculator and say, okay, 5 times negative 3 squared plus 15 times negative 3 equals, and it should equal 0. Hopefully we realize when we plug in 0, we'd get out 0, right? 0 squared times 5 is 0. Plus 15 times 0 is 0. So those both give us correct answers. Okay, let's look at one final example here. Let's say we have 9a squared minus 25 equals 0. Okay, so does it equal 0? Yes, check, right? That's always, always, always our first thought. So we're going to look over here and see if we can get this to be two things multiplied together. So can we factor that? Yes, we can, right? This is a special case. It's two terms, it's subtraction. So a number times itself, that gives us 9 is 3, and we take half of the exponent. A number times itself, that's 25 is 5. Okay, so this factors into a 3a plus 5 and a 3a minus 5. So now we can set both of those equal to 0. So we either have 3a plus 5 equals 0 or 3a minus 5 equals 0. These are just two-step equations, right? So we'll undo addition with subtraction. So we'll get a equals negative 5/3. Or if we solve the other side, right, our work should look very similar over here. Or a equals a positive 5/3. So just like we were saying with square roots, you could write your answer as two separate numbers, that's fine, but it would be equivalent of saying plus or minus 5/3, right? We could use that symbol in front as well.